Today's lesson describes more methods that are used to refine fossil fuels and how bitumen is extracted from Alberta's oil sands. Solvent extraction is a method that is used to remove impurities from a mixture. Polarity is used to remove the impurities, so depending on what is being removed, polar or non-polar substances will be used. There are two types of processes that are used when refining crude oil. Physical processes are used to separate substances, but there is not a chemical change involved. Chemical processes include cracking and reforming, and involve a change in the chemical structure of the hydrocarbons. Cracking is a chemical process which is used to break large molecules down into smaller pieces. Heat and catalysts are used in this process. Thermal cracking requires high temperatures and pressures because so much heat is required, and the byproducts are not useful. This process is only minimally used today. Catalytic cracking is the type of cracking that uses a catalyst. It does not require extreme heat, and less byproducts such as tar, asphalt, and coke are created. Catalytic cracking results in a breakdown of larger molecules into smaller molecules and carbon. This reaction only occurs in the presence of a catalyst. Hydrocracking combines the process of catalytic cracking with hydrogenation. Recall from a previous lesson that hydrogenation involves adding hydrogen to molecules. When this process is used, the larger molecules combine with hydrogen and are broken into smaller molecules. Carbon or coke is not a byproduct in this reaction. Catalytic reformation is used to turn small, low-quality molecules from cracking reactions into aromatic molecules. The reactants are aliphatic molecules, and the products are aromatic molecules and hydrogen. Alkylation improves the quality of gasoline by increasing the branching of the molecules. Aliphatic molecules are turned into more branched isomers. An example would be the reaction of heptane to form 2,4-dimethylpentane. Sulfur is a substance that is naturally occurring in fossil fuels and needs to be removed prior to burning the hydrocarbons. This is because sulfur dioxides formed in combustion will combine with water particles in the atmosphere to form acid rain. To remove sulfur from gasoline, hydrogenation or hydrotreating is used. Hydrogen is applied and reacts with sulfur atoms in the gasoline to form H2S. The H2S is then converted to sulfur and water in a Claus converter. This diagram shows how the hydrogen reacts with the sulfur in gasoline. Alberta's oil sands that are up near Fort McMurray consist of something called bitumen, which is not the same as crude oil. Bitumen is a tarry substance that is found in the oil sands. Oil sands have other materials mixed in though, such as sand and water. Bitumen is the valuable material, so chemists study the most efficient ways to extract the material from the oil sands. Each sand particle in the oil sands is surrounded by some water and then a thick layer of bitumen. Bitumen consists of some alkanes and cycloalkanes, but the majority of bitumen is made up of aromatic compounds. Consider a mixture of oil sands, water, and pentane. With what you know about the properties of hydrocarbons, are you able to answer the following questions? Is bitumen polar or nonpolar? Is water polar or nonpolar? Is pentane polar or nonpolar? Where will the bitumen dissolve? Where will the sand go? Which solution will be more or less dense? Pause here and take some time to consider your answers. Bitumen is a hydrocarbon, so it is nonpolar. Water is polar. Pentane is a hydrocarbon, and so it is nonpolar. Because like dissolves like, the bitumen will dissolve in pentane. The sand will settle in the water. Water is more dense and pentane is less dense. As a result, the water solution with settling sand will be at the bottom, and the pentane and bitumen mixture will be on the top. It is helpful to have bitumen dissolved in the pentane because then it is not as viscous and it will be able to travel through pipelines more easily. Instead of using pentane, hot water is often used to extract bitumen in real life. The oil sands are placed in a large tank with hot water, above 80 degrees Celsius, and the solution is spun around very quickly. This results in a separation of the water, sand, and bitumen as a result of the different densities of each compound. Well done on finishing this lesson. Be sure to spend some time working on making connections between theory and real-life applications.